All right, the last thing we're going to do is write a transform radical function. And so letter A, let the graph of g be a vertical shrink by a factor of 6 followed by a translation 3 units to the left. So we're going to use cube root of x in our first case. So cube root of x, so vertical shrink by a sixth. Remember what we're going to do is we're going to multiply it to the entire function. So that's all we do. That's the first thing we do, and that's it. Then it says 3 units to the left. Is that inside or outside? Left and right is always inside, so therefore, I'm going to extend this a little bit. 3 units to the left means I am going to go plus 3, opposite. Okay, so if I read it vertical shrink by a 6, that is true, and then plus 3 means I go 3 to the left. And so that is our new rule. Let's try the second example. Given the function f of x equals a half, create a function rule for g of x where f of x is shifted up 2, left 4, and vertically stretched by a factor of 2. Now x to the 1/2, what does that mean? How can I rewrite that? So remember, that is just the square root of x. Okay, so just rewriting it is nice, so let's start with that. Now we're going to shift it up 2 means I'm going to add 2 to the very end. Now left 4, that is going to be inside. So let me write this over again. So square root of x, left 4 means plus 4. So remember, left and right is inside. And then we'll write the plus 2. Now it says vertically stretch by a factor of 2. So that means we have to multiply 2 to the entire function. So it's kind of like our absolute value. You only distribute it to the front. Here, don't put it inside of the radical, and then to the back. So this final function is going to be g of x equals 2 square root of x plus 4 and then plus 2. Okay, so try these final 3, getting a little bit of extra practice, and pause the video and try it out. All right, so hope you tried this out. X to the 1/3, remember you could write that as cubed root of x, and then I applied each one individually. So vertically shrink by a factor of a half, so I applied it in the front. Shifted right 1, so that means minus 1 in the inside, and then up 5 means adding 5 to the outside. So I could just put each piece in there, and it works out okay. I didn't have to change anything. Number 3, x to the 1/4 is 4th root of x. So vertically stretched by 2, so I put the 2 in the front. There was just the 4th root of x there, right? Then reflected across the x-axis means I did the negative next. Then the last part was shift up by 7. So I just shift up by 7. I don't have to multiply anything. It was applied at the very end. So this is good. So here is the final function. Now number 5, the order matters, and so it changes a lot of things. So that was a little more challenging. So the first thing was I changed the x to the 1/5 is 5th root of x. Down 5 is just minus 5. Reflect across the x-axis. So that means I applied a negative to the entire function. So I had to distribute the negative. So it becomes negative in the front and distribute it to the back. That actually changed it to a positive 5. Then vertically stretch by a factor of 3. So that means I multiply 3 to everything here in this function. So therefore it's negative 3, and then multiply to the back. 3 times 5 is 15. So the final function is negative 3, 5th root of x plus 15.